Hey guys, it's your Wednesday asynchronous lesson. It's about the rest of the trig derivatives. Now I'm going to give you a little hint. The first 4 slides that I'm going to go over here are going to be how you generate the answer using the quotient rule. So if you think you might need a little bit of extra practice on the quotient rule, or you really forgot your trig identities, like sine squared plus cosine squared, or you forgot like that secant was the reciprocal of cosine or things like that, you might want to watch the next 4 slides. You feel very comfortable about that? Jump down to where I hit to slide 6 where there's a chart, copy it down in your notes. The next slide will be about how to remember a shortcut. And then we're going to do 4 practice problems. But so the first 4 things that I'm going to go over are really just generating it, but you're never going to have to do that again. It's just a little practice on quotient rule and other identities. Okay, so let's get started with that. So the first type of problem here, we have the derivative. Remember, this symbol right here means the derivative of tangent. So the first thing I wanted you to remember from your Algebra 2 and pre-calc days was that tangent is the same thing as sine over cosine. Let's try to write that a little bit better. Sorry about that messy handwriting. So we have the derivative of a quotient. So let's do the quotient rule. Low, D high. Don't forget to make sure that you are making a multiplication sign, and it's cosine times positive cosine, minus high, keep the high function the same, times D low, the derivative of the denominator, which in this case is negative sine. You could either put parentheses or make sure that you put that multiplication sign all over the original denominator squared. Okay, I'm going to simplify both of these. Remember that when you're trying to square an entire function for trig, that's when you put the exponent right there. So it's going to be cosine squared and then the plus sine squared because of the 2 negatives being multiplied together. And then we have cosine squared on the bottom. Now, you may not have had a singing math teacher, but cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. It's an identity. So there we go. And do you guys remember the reciprocal function of cosine? 1 over cosine is the same as secant. So 1 over cosine squared is secant squared. And there is our derivative. So a very long way of saying that the derivative of tangent is secant squared. You're going to notice that the functions often look very similar. So we're going to have the derivative of cotangent this time, which is the same as saying the derivative of cosine over sine. So we're going to do very much the same thing, starting off with quotient rule, low times the derivative of the denominator. That's what D high means. Excuse me, derivative of the numerator. Let me just say that again. Low, D high, so low, the denominator, times D high, the derivative of the numerator, minus high, the numerator, D low, times the derivative of the denominator, all over the original denominator squared. That was a quotient rule. Now we go ahead and simplify the numerator. We have negative sine squared x. Again, I want to remind you, when you put that little 2 there, that means you're squaring the whole function. Okay, so we have that. All right, you see that both terms in the numerator are negative. I'm going to factor out a negative so that I have my sine squared plus cosine squared. Song still applies. Cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. It's an identity. So negative 1 times 1 sine squared x. Did you notice I changed the key completely and I just sang them like 2 minutes apart from each other? That's why I'm not very good at singing. Okay, so what is the reciprocal of sine, or what is 1 over sine? That's the same as cosecant. So this is the same thing as saying negative cosecant squared. So again, the derivative of cotangent is negative cosecant squared. Again, I want to remind you, you're not going to have to do all this quotient rule type stuff and things. I just think it's a good reminder because it helps us remember that sine squared plus cosine squared is 1. And it also helps us remember that 1 over cosine is secant and 1 over sine is cosecant. Just some little memory type things. So again, the derivative of secant is the same thing as asking you for the derivative of 1 over cosine. So let's use the quotient rule again. Low times the derivative of the high, minus high, times the derivative of the low, all over the original denominator squared. Let's simplify that numerator. Now I'm going to do something that might be a little tricky to you, okay? First of all, cosine x times 0 is 0. We have a minus, we have minus, that's same as a plus. I'm going to leave that 1 there, and I'm going to leave that positive sign there, and then I'm going to write the denominator, instead of writing it as cosine squared x, I'm going to write it as cosine cosine. I'll tell you why. Because 1 over cosine is the same as secant x, and sine over cosine is the same as tangent x, and that is the derivative. So the derivative of secant x, tangent x. Okay? Let's do another one. The derivative of cosecant. Well, we know that cosecant is the reciprocal function of sine. So we are basically asked to do the derivative of the quotient 1 over sine x. So let's do it. Low, which is the denominator, d high, the derivative of the numerator, minus high, the numerator, d low, the derivative of the denominator, all over the original denominator squared. Low d high minus high d low, all over low squared. I'm going to do the same thing I did last time. Sine x times 0 is 0. I have a negative 1 remaining. I have a cosine remaining. I have on the bottom sine squared x, but I'm going to write it as sine x times sine x. So you can see that the first part of the fraction is the same as negative cosecant x, and the second part of the fraction is cotangent x. So there is my derivative. The derivative of cosecant is negative cosecant cotangent. Now, if you're just joining us because you fast forwarded, welcome to the chart. And if you're joining us for the first time, hello. Okay, so I have this little thing that I want to tell you. You really can't get away from like just here are your 6 derivatives. Here's the chart. Put it in your notes, memorize it. But I do want to point out something. You might notice that I have the blue over here underlined. And the reason why is the derivative of cosine, the derivative of cotangent, the derivative of cosecant. Every single time I say the derivative of look at how the derivative starts. It always has a negative out in front. So that's something to remember. Number one, anytime if I say, hey, what's the derivative of cosine? The first word out of your mouth should be negative. Okay? What's the derivative of cotangent? Oh, you heard the co, negative. What's the derivative of cosecant? Oh, I heard the co, negative. So that's one thing to know. Another thing is, here's a little trick that was taught in the book Calculus for Dummies. I don't think it's a very dumb trick, though. I think it's actually a really smart trick. Okay? That is that you come to a test or a quiz or something like that, and you're not really good with the other 4 trig derivatives. We're going to do cosine and sine a ton of times in this class, so it'll just be second habit to you. But what if these other ones? If you can remember to write secant, secant, tangent, cosecant, cosecant, cotangent, put a negative in the middle, it's going to help you remember the other 4 derivatives. Now, you might be saying to yourself, why would I write this if I have to memorize the table? This is another thing to memorize. I don't know if I'm going to do that. But here's the trick. This is what's cool about it. If I ask you, what's the derivative of secant, that guy, what's left over in its row? Secant x, tangent x. Ah, and that's the answer. Oh my goodness. Does it work for all of them? It sure does. If I ask you, what's the derivative of tangent, what's left over in its row? Secant x, secant squared x. That is the derivative of tangent. What about in the bottom row? Now remember, you have to remember to put that negative in the middle. But again, what's the derivative of cosecant? Negative cosecant x, cotangent x. And what's the derivative of cotangent? Cosecant x times negative cosecant x, or negative cosecant x squared, or negative cosecant squared x. So that's just a thing. Secant, secant, tangent, cosecant, cosecant, cotangent, put the negative in the middle, and then whatever one you're asked about, whatever's left over in its row is the answer. So let me just show it to you again. Say like, what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. You heard me say the derivative of cosine, negative sine. Then it says, what's the derivative of tangent? Ah, I forgot it. If you can remember, secant, secant, tan, and then you just circle the tangent, what's left over? Secant squared x. So it's just a little trick. Go with it if it's worth it. Don't go with it if it's not worth it. That's okay. Just make sure that you get this chart copied down in your notes or you have it handy. Please don't be flipping through your notes trying to find it in the middle of a test. It's a real pill to take. All right. So let's do 4 example problems, and so that you can do your practice problems and other problems. It says f of x is tangent x, find f prime pi over 4. So f prime means find the derivative. Secant x. So the derivative, it was like secant, or sorry, I just even said it wrong, didn't I? Secant tangent. Oh, that's the first row. The derivative of tangent is secant. So secant squared. So we're going to say that the derivative is secant squared x. And if you would like to just write secant x, that's also fine too. Okay. So when I say I want to find f prime over 4, I am basically finding the secant of pi over 4 times the secant of pi over 4, or squaring my answer. It's up to you how you want to write it. If you want to get the answer and then square it, that's fine. Or if you want to write it like this. Now, you still have to remember your trig identities. Oh, no. All right. So what is pi over 4? The coordinates right there are root 2 over 2 and root 2 over 2. Reminder that secant x is the same thing as 1 over cosine x. Okay, so the secant of pi over 4 is the same as 1 over the cosine of pi over 4, which is this value right here. So root 2 over 2 times 1 over root 2 over 2. Or you could just choose to write it as 1 over root 2 over 2, put parentheses around it and square it because of this term right here. Okay, so we have this. I'll just go straight across. So I have 1. Remember, when you multiply fractions, you just multiply a numerator to numerator. So root 2 times root 2 is 2. And 2 times 2 is 4. So we have 1 over a half. Do you guys remember keep, change, flip? Keep, change, and flip. So we get 1 times 4 over 2, or 2. A lot of things going on there. The lesson is what's the derivative of tangent, which is secant squared x. But you had to know how to plug in pi over 4. You needed to know your unit circle and its coordinates. You needed to know that secant was the reciprocal of cosecant. So whatever you needed to know on the unit circle, that the x coordinate is related to cosine. So then you needed to know that I do 1 over the cosine value. So even though it's a straightforward derivative problem, it had a lot of prerequisite skills in it. And that's really what makes calculus hard. It's not oftentimes the calculus. Most of the time, the calculus you'll be able to do. It's all these little algebra skills that come into play. Okay, so let's go back. By the way, remember the tangent graph? We used to dance at boop, 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 woo, boop, 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 woo. All the little boop, boop, boops are at pi over 2s. And this one was asking you about pi over 4. So it's on the woo side. So it's telling you the slope at pi over 4 is 2. So it's on this upswing when I would go boop, 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 woo. It's on this upswing right here. That's what you're being told. Okay, next problem. F of x equals cotangent x. Find f prime of 6. So remember, if I did that bottom row, it was cosecant x, negative cosecant x, cotangent x. So the derivative is negative cosecant squared. So I'm going to do f prime x equals negative cosecant squared x. You can write it like that, or you can write it as negative 1 times cosecant x times cosecant x. It's up to you. It's going to appear like negative cosecant squared x, but if you have to plug in a value, it might really help you to separate it. So you can write it as negative cosecant squared x pi over 6, or you can just do negative 1 times the cosecant of pi over 6 times, again, the cosecant of pi over 6. Well, here we're back to our normal thing, guys. What is the cosecant of pi over 6? We're back to the unit circle. Pi over 6 is over here. The coordinates of over there are root 3 over 2 and 1/2. So cosecant is the reciprocal of sine. So that means I am trying to find 1 over the sine coordinate. So this right here is the same as saying negative 1 times 1 over 1/2 times 1 over 1/2. Maybe you know that 1 over 1/2 is 2. 1 divided by a half, like how many halves go into 1? 2. Maybe you have to take that extra step of multiplying straight across. So you get -1 times 1 over 1/4. And then maybe you have to take that extra step of doing keep, change, flip, but eventually you will get -4. So what you are telling me is on the cotangent graph, that the slope is -4. So on the cotangent graph at pi over 6, my graph is going down at a slope of -4. That's what's going on right there. Okay, let's try 2 more. This is kind of what your Khan Academy is about. If f of x is secant x, find f prime of pi over 4. So let's do f prime of x equals, and if you do that little shortcut, the top row was secant x, tangent x. And remember, if I'm trying to find the derivative of secant, it's what's left over. So secant x, tangent x. Or you can just go, Miss Kulkarni, I really don't get that shortcut thing. I'm going to just use my chart. There it is. There's the derivative. Okay. So now we're going to plug in pi over 4. Now, ladies and gentlemen, when I plug in pi over 4, that means I'm looking to the unit circle. I want to remind you that pi over 4 is the part of the unit circle where the coordinates are the same. You just have to, where the values are the same. It's just maybe the signs that aren't the same. Okay, so what is secant? Secant is 1 over the cosine value. What is tangent? Tangent is the y coordinate divided by the x coordinate. Okay, so a couple of things here. Keep, change, flip over here. All right, and these guys are the same coordinate. Do you notice that? √2 over 2 divided by √2 over 2. So that's just 1. So I could have 2 √2. Now remember, in calculus, I don't have to simplify this step right here where all the fractions are. I could leave it that way. But Khan Academy is a multiple choice problem, so you kind of have to simplify it a little bit. Now, sometimes Khan Academy is a multiple choice, and it will accept or a free response. And when it's free response, it will accept the non-rationalized function. But I want to remind you, we had this thing called rationalizing denominators, where you don't have a radical in the denominator. And the way to get rid of it is you multiply both the numerator and the denominator by the radical. So then you would get 2 √2 over 2, and then the 2's would cancel. So the answer could be √2. Okay, again, the outcome of the day is that you can just find the derivative. So if f prime or f is secant x, then f prime is secant x tangent x. But then right now we're doing a lot of review of plugging in values from the unit circle, evaluating trig functions on the unit circle, and getting a numerical answer. This one actually had rationalizing denominators. Okay, one more to go. F of x equals cosecant x. What's f prime at pi over 2? Let's remind ourselves, if we're using the little shortcut help, cosecant, cotangent with a negative in the middle, and I asked you to find cosecant, so negative cosecant and a cotangent, or maybe you just have your chart handy, you just jump right to the answer. So we go f prime x equals cosecant x cotangent x. I forgot the negative. Let me go put that in there. F prime, it's asking me for pi over 2, so I want negative cosecant at pi over 2. And I want cotangent at pi over 2. Let's draw our little unit circle right here. We have pi over 2 at the top. And its coordinates, if you remember, are 0 and 1. I want to remind you that cosecant is the same thing as 1 over sine. So we are saying, what is the 1 over the y value? So we have a negative, and then 1 over the y value. So we're going to put that there. And then cotangent is the same as saying cosine over sine. So the x value over the y value, the x value was 0, the y value was 1. So our answer here is going to be 0. And there you have it. So what is the outcome for our asynchronous today? Well, the outcome of the asynchronous today is that you have this chart in your notebook. And now from now on, whenever you're asked any of the 6 derivatives, you can give me the derivative. The secondary outcome of today is that you're able to plug this in and also evaluate. So really big things about this particular video today The first part, just getting the derivatives down. The second part, being able to evaluate complicated trig functions. So hopefully that worked out well for you, and you'll be able to do your Khan Academy assignment. Remember, your Khan Academy is basically a one-time through sort of deal. I hope that you're able to do it, but ask questions if you are not. Okay? With that being said, have a happy Wednesday, guys.